Hi there, welcome back to the Dev Owl. I am Roman and today I'm going to start a new very small video series about maybes, about options and about if maybe is actually an option for modeling your domain. This is a small 3-part video series. I think it will be 3 parts in the end, and I hope that even if you're working with F# or any ML style language, that you can actually get something out of this and learn something in this video series. Some remarks to start with. If you actually want to support this channel and you like the stuff I'm doing, you have a couple of options. The first one is, of course, the normal one. Just give me a subscribe, a like, a comment. It helps me tremendously in this whole YouTube algorithm thing. If you want to support me financially or in any other kind of way, you can go to my Ko-fi page and buy me a coffee if this is something that you like to do. So, without further ado, los geht's and start with this new series. So, what can you expect from this video series? So, in this first video, I'm going to introduce to you the basic cases where we are normally using null in our applications. And then I want to show you the problems that might arise when we are actually using null in those situations. And most of these problems come from not being explicit. So I want to introduce to you options or maybes that allow you to be much more explicit in your applications. Then in the second video, I want to show you that options are a really nice tool and really nice new thing in your tool belt. But I also want to show you that they are not like the silver bullet, because when you are using options in your domain, in your business behavior, it becomes obvious pretty fast or pretty quickly that options are also not explicit enough to model your actual business behavior. So in order to be able to solve this, I want to introduce some types to you then, and I hope that with the help of some types, you will actually be able, after this video series, to create much better data models for your business applications, for your domain modeling, which will allow you to write software with much less bugs, and that can be reasoned about later on much easier. There will be a lot of code in this video series, and there also will be a lot of F# code in this video series. So if you have never actually seen F#, don't be afraid. I will give you the basic introduction and the basic syntax that allows you to actually work with F# and to follow my examples. If you have worked with F#, if you're using it in production, or you have worked with any other ML style language like Elm, Haskell or Camel or whatever, this will be very easy for you, of course, but you can just glance over it, and I hope that in the end of this video series you will have learned something new nevertheless. So I hope that I can show you how important it is to build really nice data models in your applications. So the hardest part when creating content or good content for conferences or for videos like these on YouTube is to have a good point in your content. And in order not to lose this point, I give it to you up front. So this is the point of this video series, and giving you this up front, the point is prefer explicitness over implicitness. This is what the whole video series will be about. This is what I prefer all the time. So you can take this with you, and we will come back to this a lot. So there will be a domain we're talking about in this video series in order to have a frame where we can actually move in or do our stuff in. And the domain I've chosen for this video series is something different to you. I hope not the pretty standard accounting stuff or customer and user stuff. So we are going to talk about in this video series about the scuba diving domain. Okay, we are going to start with null and its uses. So here we have some C# code in this case, and I think you can read this pretty easily if you have worked in C#, Java, or any other of these kind of languages. So up here we have the wetsuit size of our trainers. So each trainer and each participant in our scuba diving courses needs a wetsuit, and these have 3 sizes, S, M, and L in our case. And here we have a class with the trainer. And this trainer has some ID, which is in our case a GUID, and it has a name, which is a string, an age, and it also the trainer also has a wetsuit size. So where are we using null when we are working in this domain? So this is a lot of code here, I know, but I think it's not that hard to read it. So we have a repository, and this repository has a function to find a trainer by a name. And so in here, what we have here is we have a SQL query, and then we have a try-catch block, and we get a reader somehow, and read through the SQL query to the result of the SQL query, and then we create a new trainer. And if we have some rows, if we find something here, we create a new trainer and fill it with the values, and in the end we return a trainer. And we also have some error handling in here where we are catching exceptions, etc. So where are we going to use null in these cases? So the first one is we use null if we haven't found a trainer in here. So the reader has, if the reader does not have any rows, so we didn't find anything in our SQL query, we return null. So we return null if we don't find a value. But we also use none for late initialization. So we have a trainer in here, and if we go back to the first slide, we see that all these are public getters and setters. So if we create a trainer in here, all the fields are initialized with null. And just later on, we use late initialization to actually fill those fields of the trainer. We also use null for optional values. So it might be possible, because of the database schema, for example, that this field here is actually null. So we don't set it all the time. And we also use null in this case here for error handling. So what are we doing here? We are catching an exception that might have occurred when we're actually asking the database or querying the database. And then we log the message. I know this is not the best thing, but I'm pretty sure that all of you have seen this already, or in your past, or I have done this as well, I'm guilty. So we catch an exception, we just log the message, and then we say, okay, we return null just to show that something went wrong. So what other cases for null do we have? We have null for partial functions. So what do I mean with this? Well, if we have a look down here, we see that for the wetsuit size, we are parsing a string. So we say parse the size, and then we assign this to the return value to the wetsuit size. So what we are doing here is we have this parse function, and it takes a string and it returns a wetsuit size. But it only returns a wetsuit size when the string or the character actually here is an S, an M, or an L. Then we return an instance of the enum. But in all other cases, we return null. And if we think of this, this is actually a partial function. We don't have a look at the whole strings. We only return a reasonable result when we actually have S, M, or L. So what are the cases we are using for null for in just in these small examples here? We are using null for late initialization. We are using null for partial functions. We are using null for values not found, for optional values, and also for error management. So this is a lot, right? And all of this can be seen or can go under the umbrella of dealing with uncertainty. All those things are somehow that we are actually dealing with uncertainty in our applications. So, and the thing is that none of those things are made explicit. We never actually know if we have to deal with null in those cases or not. So this is sort of the point of the videos, right? Nothing in here is explicit. Everything is implicit. So if we are then dealing with all this uncertainty, we need to check what can be null, because everything can be null. So we have the trainer. This can be null if we don't find it. So we need to check for null. We also have seen that the age of the trainer can be null. So we need to check it. And we have also seen that the wetsuit size of a trainer can be null because the result might not have been parsable. So we also need to check this. But why don't we check the ID in here? And why don't we check the trainer name in here? Because we know that it can't be null, right? Because the database field can't be null, or this can never happen, right? So I'm pretty sure that at this point in my application, this variable or this field in an object can never be null. How often have you thought about this? How often have you thought like this? And then in the end, we get the runtime exceptions, we get all those problems, and we say, this can't happen. This should never have happened. Who is to blame for this? So I think null has a lot of problems because we have to check everything. And in the end, nothing is really checked, right? So the main problem, in my opinion, is that null is a member of any type. So every time something is returned from our functions, it can also be null. So we need to check this. So any value can be missing at any given time. And this is never explicitly stated, which is the point again, right? So, and the thing is that null is viral because everything can be null. In the end, we had to check everything to make sure that we are not actually dealing with some null values or some null properties. And because everything needs to be checked, let's be honest, a lot of time nothing is checked or only the main parts are checked. But in the end, we get a lot of runtime, null reference exceptions, etc. So actually, that's pretty bad. Eh? So maybe there is help. How can we actually get out of this? Well, there is this video series, so there is help, of course. There's one thing called nullable reference types or nullable types in C# and Kotlin and a couple of other languages now. And I'm not going to talk about this, but what we can actually do in here, for example, in C#, if we flip this feature on, it means that all the values that actually can be null need to be marked with a question mark in here. This is really nice, and this is some recent feature that was added to C#, and we also have this in Kotlin and other languages, but this is not what I'm going to talk about in this video series. I'm going to talk about options or maybes. So in F#, they are called options. In Haskell or Elm, they are called maybes. So what is this kind of type? So an option here is some kind of pseudosyntax, and you see here that this option has some generic type parameter in here, which means that we can use this later on in the type. And an option consists of actually two different instantiations, so to say. So you can actually create a sum of something or a none. So with this option, you can actually make it explicit that a value might not be there. So you say you have an option of a string, for example, in here, or an option of an int, and this tells the compiler and another programmer or me next week that this value might be missing at any point in time. So we need to cope with this. So we have two cases again, and in the first case we actually have the value, so we have a sum of this t, and in the other case we don't have this value. And what can we do with this option type? For example, we can make partiality explicit. So we have those parse wetsuit size function that I have shown you earlier on in the C# code. But now here we have the actual F# code. And if you have never seen F#, I'm going to explain this in a sec. If you have seen F#, you can fast forward this a couple of seconds. So what we actually having here is a function called parseWetSuitSize. And the thing is that this function has a return value of option wetSuitSize. So this is what we're returning in the end. So we have a function definition. We use the let keyword in here, and the name after the let keyword is the name of the function. And then we see here that we have one parameter for this function. And we have a type parameter or a type annotation here, which says that the size is actually a string. But this is completely optional in F#. Then we have the return type that I have just talked about, in this case an option of a wetSuitSize. And then we use here pattern matching. And pattern matching is something that you can think of something similar to switch case statements, but on steroids. And I will talk about this later. So in this case, we have pattern matching and we say, just imagine switch case the size. And in the case of an S, we return a sum of a wetSuitSize S. So in all those cases, we actually found a wetSuitSize, we were able to parse it, and then we return a sum of the wetSuitSize. And in all other cases, this is what the underscore here is meaning. So in all other cases, we return none. So in this case here, in the L case, we have the sum, which is kind of a constructor function for the sum case. So with this function, we are actually creating an instance of the option type. And we put in the wetSuitSize L in here. And this is what I just said to you, that in all other cases, this function is returning none. And there is no return keyword in here because F# is an expression-based language. And so this whole thing is one expression, the whole pattern match expression. And in F#, the last expression in the function is always returned. So in this case, the return type here is returned. And this is really nice now, because if we compare those two functions, we have here the implicit case where we say, okay, we return a wetSuitSize, but we might also return null. So you better check this. But in this other case, we are being much more explicit, right? So we are telling the system and also the compiler that we are returning an option of the wetSuitSize. So this value might be missing. Better check it. The question is now, how do we get the value of this option? How do we get it out of this? Because sometimes it's some with the value in there, sometimes it's none. So if we find our available wetsuit, so we give a size and then we ask some database for a given wetsuit. How do we do this? Well, we use again pattern matching, and in this case we say, okay, we match the size, what we get into this function, and if it is sum s, so now we have unwrapped the value, the s value that was wrapped with the sum. If we have this, then we can call some function that actually gets the available wetsuit from our database, and we use this s then in here. But the nice thing now is that this is not compiling. Why? Because we haven't actually checked for our none case. So because we told the compiler, hey, there is an option coming in, it's also possible that we have no value in here. So in order to make it compile, we need to introduce another case in this pattern matching, which is the none case. And the question is, what should we actually do if we say, okay, here is a size, find the available wetsuits for this, but now there is none. What should we actually do? What should we actually return then? What should we actually do in our business or in my application? And I think this is a good place, those questions that arise here, to actually talk with the business, think of what should happen if this happens in my system. And this is a really nice thing, I think. Okay, we had another problem with null. We had the problems that we don't make it explicit if we haven't found a value. So this was the case in here, reduced it down a bit so we get the data, and if the reader has row, we return it, and otherwise we return null. So how can we actually solve this with options and F#? Well, we have this F# function, which looks pretty similar, I guess. So we have here the name of the function, find by name with the parameter, and we say, okay, now it returns an option of a trainer, not a trainer anymore. And we also have the try with, which is the try catch in other languages, and we have the if then and the other cases. The difference is now that in here, if we actually found something, we return some trainer. So we make it explicit that we actually found something. And if we didn't find a trainer, we return none and not null anymore. So we made it again explicit in our return type that we are dealing with something that is missing. Okay, let's come to the point where we can use options to make optional values, actual optional values, explicit. So in order to be able to do this, I need to introduce another concept from F# to you, which are records. So records, you can just think of a struct or a simple class, a JavaScript object with no behavior in there. So it's just a type that has a couple of values in there. So we have seen the class trainer in the beginning in C#, and this is pretty much the same. So we have an ID, which is a GUID, a name, which is a string, etc., etc. And we also have the wetsuit size. The difference with F# records is that we can't really create them with empty fields. So each time I create an F# record, I need to provide all the information for this record. This might be a big problem for us because, as you have seen in the C# code, we initialized our trainer class with all the values null, and then later on we use this for late initialization. So when we are actually doing this, we need to create a trainer like this, but with an ID, a name, and an age. So this is the syntax to create a record instance in F#. But we have a problem now because the wetsuit size, as we have seen, might be not there because we couldn't parse it from the database, or it's just not in the database. So what can we actually do with it? Well, we could change the type of our trainer in order to make the wetsuit size an option. And when we are doing this, we are again being explicit in here. So then when we create a trainer and we don't have the actual wetsuit size, we just instantiate it with none. Okay, so let's use options to make arrows explicit. So let's have a look at our code again. And in here, we said, okay, we want to catch an exception. And if we had one, we just want to return null. This is not the best thing, but we've all seen it. So let's have a look in here. How can we actually change this? Well, we could change this by catching the exception. This is the try with syntax in F#, using pattern match for the exceptions again. Then we could log the exceptions if we really wanted it. And then we can actually return none. But if you have a closer look to this, we see that we have introduced another problem now in our F# code, because now we have two none cases. We have none if we haven't found a trainer, and we have none if there was an error. And this is not very explicit again. So what can we actually do to solve this? Well, put this on the side, and we can actually introduce a new type, which is called result, which looks pretty similar to options, but it is a generic over two values. So the option only can wrap one case, and the result case can actually wrap two cases. So the cases of a result are called OK and error. And if we have actually a result, so if everything worked fine, we can wrap our result in an OK case, which we can later extract similar to the option type in a normal pattern matching expression. And if we don't have a value, or if there was actually an error in our application, we can wrap this here in another type. So in our case, we could say, okay, now we have a result of option of a trainer and a string. This looks a bit bloated, but it's really nice because we say, okay, if the reader has some rows, so if everything worked okay, we say okay, and then we put some trainer in there. If it didn't work out, we say okay, the function call actually worked, there was not an exception, but we didn't find anything. So we say okay of none. But when we had an exception, we can wrap, for example, the exception error message. We could also wrap the whole exception if we wanted to in this error. So because this is a string, this T error here in this case is a string. So the real nice thing is that we have an explicit differentiation between the value is not found and an error case. And this might help us later on tremendously. So to wrap this first video up, options are a really nice new thing, and they actually help you to make it explicit when we deal with values that might not be there. And they are an easy way to make certain functions total, which is really nice. And what is really cool is that they do not compile when we are missing a case. So we are always forced to actually work or think of the case when a value is not there. All right, this wraps up the first episode of this mini-series. In the next episode, we are going to talk about why options are not the best thing or the best tool for modeling your business applications. And I will introduce some types to solve all the problems that arise when we are using too many options in our code. And again, it is about the point of prefer explicitness over implicitness. So I hope that you join me in the next episode. Support me on Ko-fi if you like. Give me a like, give me a subscribe. Ask me anything you like. See you around. Bye bye.